Hey guys, this is Jackson, and in this tutorial we're going to be taking a look at building an infinite random world generation algorithm very similar to how it works in Minecraft. So we're going to be walking through the world. It's going to be made out of blocks, and those blocks are going to be existing in specific chunks, all of the same size, and as you move through the world, new chunks are going to spawn in, old chunks are going to spawn out, and the structure of those chunks is going to be determined from a noise function. So we're going to get valleys, hills, and all that kind of stuff on the surface, and then beneath the surface we're going to be using a separate noise function to generate caves and holes and things like that. So we'll see how far we get. We'll get through it today. We'll see how far we get through today, and then I might have to split it up into a few videos in the future and just see how much we can do. But that's the basic idea. So I'm just going to launch Unreal Engine, and I'm just going to crack open a new project. So just give this a sec. I might just take a sip of water real quick. Fuck, I've run out. That was like so unsatisfying, just the tiniest drop of water at the bottom. So games, next. Third person template, next. Blueprints, we're going to attempt to do this in blueprints and just see how it goes. A lot of people do this in C++, but I have got it kind of working in blueprints. It's not perfect, but like it's still the general idea, so we're just going to try and do it in blueprints and we'll just see what happens. I'm just going to call it MC for Minecraft YouTube tutorial. That's ugly as fuck, but I'm probably going to delete it after the tutorial anyway, so it doesn't matter. Okay, now just give that a sec while it boots up. I'll show you my plan for what we're going to try and do today. So we're going to try and get the endless tile generation down. So the way that that's going to work is we're going to be tracking where the player is. We're going to be converting the player's world location into a set of coordinates, and the coordinates are going to be just integers representing spaces that are a arbitrary size apart. So like the chunk size might be like 300 units or whatever. So when you're on 300x, the coordinates of that chunk is just going to be 1 on the x and 0 on the y. Hopefully that makes sense. We're going to be using an event tick to see if the player has changed coordinates, and when the player does change from one coordinate to the next coordinate, we're going to remove all the chunks that are out of the new render range. The render range being the distance from the player to whatever range we've defined around it. So it's going to remove all the chunks that are outside of that range, and it's going to load in new chunks that are now within the range. And basically the chunks for this video are just going to be planes. They're not going to have any fancy noise on them or anything. So we're going to try and do all that today, and then in the next couple of videos and whatever, we'll look at using the simplex noise plugin to get some hills and things on the surface of those chunks. So that's enough of me talking shit. Let's just give this a crack and see if we can actually get it to work before my brain implodes. So I'm just gonna create a new folder and call this Minecraft. I am gonna change the color quickly so that it's easy to see. Nice lush green. New plugins, fuck off, we don't need you. Dismiss, you are dismissed. Now we are going to... Oh, what the fuck? Subsurface profile. Get the fuck out of here. We are going to create a new level. Default. Control S to save. Minecraft. Right click. New folder. Maps. Enter. Go in. And we're just going to call this MC_test map. Right click. New blueprint class. And we're going to create a new player controller. And the reason we want to do everything in the player controller is so that it can be used with different pawns. So maybe you want to have different pawns running through the world, or you want to have, I don't know, like multiplayer or some shit. I don't know, it just feels like the player controller is just a good place to build this in. So in order to get the player controller to work, we're going to need to go to game mode, create a new game mode, call this MC_game mode. And inside of that game mode, we just need to set two things. So we need to tell the game mode to use our new player controller instead of the other bullshit player controller that we're not going to be using, and we need to tell it to use default pawn class needs to be our third person character, or whichever character we want to use. And the final thing to do is just in our MC test map in the world settings, we just need to go game mode override and tell it to use our new game mode. So now we'll be using our new player controller and the third person character. Okay, now that was the setup done. We're already 5 minutes in and we haven't done shit. Let's go into the player controller and let's finally get started on this generation thing. Fingers crossed we can get this to work. Okay, so let's first of all get the controlled pawn. First thing we need to do is get our controlled pawn and get its position in the world. So let's say get actor location, and then what we're going to do is convert that location to coordinates. So we're going to divide this float. Should we do this just on the X and Y or also on the Z? I kind of just want to do this on the X and Y just for simplicity. So what if I were to, so let's say divide float. We're going to promote the division thing to a variable, and we're just going to call this chunk size. I'm going to call it chunk size XY. So what we're getting out of this now is, oh, can we round a vector? Let's see. No, we can't. So, okay, so we need to break it. We're going to break it, and then we're going to round these floats to integers. And so now what we've got here, so we took the position of the player in the world space, we divide it by the chunk size, and then we're rounding it. So this is essentially giving us the coordinates of this arbitrary chunk coordinate system that we've made, where the vertices of that grid are this size apart. So if we set our chunk size to 1000, that was a lot of words. Hopefully that made sense. If it doesn't, it might make more sense as we go on. So let's just keep going. Let's set that to 1000. So let's just imagine that our chunks are 1000 size. So the grid that we're going to be using is 1000 bits apart. And then what we're going to do here is we're just going to say make int vector. Or maybe I can say make 2D vector. Vector 2D. Vector 2D. I've got a feeling vector 2D might be with floats though, so maybe we can just roll with this. So let's say make int vector. Now this here is getting the player's coordinates. So what we might do is we might promote this to a function, or collapse it to a function rather, and say get chunk coordinates. No, let's call it get player chunk coordinates. And we're just going to make that a pure function. I'm going to crack that open, and then I'm just going to add a return node. Connect those two, and then just put that in there just like that. We might add a Z later, but that's just going to be a headache for now, so I'm just not going to worry about that. So we're going to use the event tick here. And what we're going to do is we're going to have a branch. And the branch is going to check if the player's current coordinates are equal, which I don't think I can do, so I might need to break this again. Actually, maybe a better way to do this is I might just disconnect that, get rid of that, X, Y. There we go. X, Y. Just to get rid of that step. We're going to need an AND boolean here, because we're going to need to check if this is equal to an integer, and we're going to need to check if the y is also equal to an integer, and both of these conditions need to be satisfied in order for this branch to be satisfied. That's why we're using an AND node, AND for AND. And that's funny because I used the word AND when I was just making jokes about the word AND. Oh fuck, I'm tired. So hang on, let me just make this chunk size a public variable, because that's going to be toggleable. I like to put the little eyeball there next to things that we're able to edit. And the player chunk coordinates that we're we're getting the coordinates of the player and we're checking it against the coordinates that the player was at in the last frame. So what we're going to need to do is we're going to need to create a new variable which we're going to be calling last known player chunk coordinates. That's a bit of a mouthful, but it's okay. And that's going to be vector in vector. So that's not going to be public either, because this is going to be set at runtime. It's not going to be something that we're setting by default. Now I'm going to split that pin struct, and we're going to be checking the x against the x and the y against the y. Now, if the coordinates each frame, if the coordinates are the same that they were last frame, do nothing, because the player hasn't moved. They're just still in the same chunk, so we don't need to worry about any streaming. If they're not the same, the first thing that we need to do is set our last known player coordinates to this thing that we just generated. So maybe we'll have to generate that again. That's fine. So we can just put that there just like that. So now this line of execution will fire and it'll update this, and then when this fires again next frame, this check isn't going to return false again because these have now been updated to be the same. So this line of execution will only ever fire when the player changes coordinates. So as a matter of fact, we could have a custom event down here and call this player has changed chunk coordinates. And this is where we're going to manage all of our streaming and things from. Okay, so let's call that event just here. Player has changed chunk coordinates. Fuck, I really need a drink. My throat's getting sore. How long have we been going? 11 minutes already, and this is all we've done? Holy shit. Player has changed chunk coordinates. So what's the first thing that we need to do when the player changes chunk coordinates? I think we should probably spawn in some chunks. So let's create a new function and call this spawn new chunks within render range. The first thing that we need to do before we do that is probably create a chunk blueprint. So let's go new blueprint class, type actor, and call this MC underscore chunk BP. We'll give you a, can we just give you a plane? Probably. I don't really know how wide that plane is apart, but if I change the snapping to that and then hit Alt J, we can view it from the top. It looks like it's 100 across. Can I measure it? I was trying this before, but I can't remember how to use the measuring thing. So let's make you 5 times, so that should be 500 across now. It looks about 500 across. Let's say that's 500 across. So when we're spawning new chunks in the render range, we're going to need to use this grid that we're imagining exists in the world. So we're going to need a few for loops, not a for each loop, a for loop. A for loop for the X positions and a for loop for the Y positions. And the loop indices that we're going to be using, we're just going to need a new variable. So I'm just going to call that render range XY. And this is going to be a type integer. And this can be public because this can be editable. And I'm going to say times integer multiplied by -1. And then that's going to go in the first index, and then the render range can just go into the last index, just like that. Why are you being stupid for? Okay, good. So I'm just going to copy that, and I'm just going to plug that over here. So what this is doing is this is generating a grid of points of whatever width we've defined here. So let's just start with like, I don't know, like 5 or some shit. So it's going to start at -5 and it's going to go through to +5. And the center point is going to be at index 0. At the moment, the values that these are going to be, let's actually, before I talk about that, let's just promote these to a local variable. I'm just going to call this temp x there. Just because I don't, oops, sorry, hang on. Let me finish what I'm doing and then I'll talk. I might have to take a break in a sec because I feel like I'm not making any sense already and we're only 10 minutes in. I like to promote these to local variables here because otherwise you get fucking big, long spaghetti things and things are all tied up and messy, and then when you start to have problems and you're trying to troubleshoot, you just drown in the spaghetti and you die. Or when you try to review this thing later on down the track and you can't understand what the hell it's doing because it just looks like a cobweb. So I just try to keep things neat. I might also just label this as X and Y, just in case we need to look at the order of them later. Okay, so what this is doing is this is generating a bunch of indices in a grid. The next thing that we need to do is, if we're going to be spawning chunks within a render range, we need to make sure that this grid is being generated around where the player is. So let's grab our player chunk coordinates thing that we used before, and we're going to say add integer, copy, paste, add integer. The temp x is going to go and be added to the x, and the temp y is going to be going in there and added to the y. And now what this is going to do is, each time this loop is run, it's going to be generating this grid of points around where the player is, and then that's what we're going to be using to be spawning the chunks. So this is when we can say spawn actor from class. So oopsie daisies, that can go in there, and it's going to be MC chunk BP. Now the spawn transform, we don't really care about the rotation or the scale, so if I just plug that into there, that should just be fine like that, and it'll use the default scale and transform. The location of where the chunks are going to be spawning is going to be this index, which is on our imaginary grid, times by a float value, which is going to be our chunk size, and then that'll give us the world space where we can spawn it. So that'll go into X, and then we can also go the same for Y. And they're just going to be at 0 for now. We could do 3D later, but I'm not gonna. So now what we'll get is, whenever we change coordinates, this is running every tick. Whenever we've changed coordinates, let me just add a little comment here. Are the player coordinates, I'm just going to make sure that it's specific and descriptive, are the player coordinates the same as they were last tick? True, do nothing. False, run this event. Player has changed chunk coordinates. And when the player changes chunk coordinates, we're going to spawn new chunks within the render range. And the render range is 5, chunk size is 1000. What size do we make our chunk BP? 500. So we're just going to need to change the chunk size to 500. I might actually make that, yeah, 500 actually. Let's make that 500. Or should I make it 600 just for a laugh so you can see the distance between them? Actually, let's just do the default first and make sure that works, and then we'll demonstrate afterwards. So this is gonna spawn new chunks whenever we approach the edge of the map. So let's just test that out. Here we are. We're in the world, and as you can see, nothing is happening. Or is there? It's happened. Cool. So as we're running, you can see that the world's just infinite. The chunks are spawning all the way off there, and it's very laggy. So give me just a second. I'm going to go into my settings, engine scalability. They're not even up high. Holy shit. I'm just going to put that low, just because my computer is an absolute piece of shit. I think why it could be lagging actually. So what this is doing is this is also spawning tiles on top of each other every time you change coordinates. So what we could do is we could have a check in here, a branch. So when it generates the indices, before it actually spawns a chunk, let's first check if a chunk has already been spawned at that position. And the way that we could do that is, why don't we take this here, put this here, make in vector, and we can promote this to a local variable, and we'll just call this what? I guess it's just chunk coordinates. Chunk coordinates. These are the coordinates of the chunk. It's taken the player position, added the loop values to it. Now we have some chunk coordinates. So after we generate a new chunk, what we could do is we could grab these chunk coordinates and we could add this to an array. The array is going to be saved as a variable, and this is going to be called current spawned chunk coordinates. Boom, just like that. I have a feeling that we should probably also save a reference to this as well. So let's just say add array. So this is an object reference to the actual chunk that's spawned. So we're going to create a new variable there and call this current spawned chunk references. So we can use this list later when we're destroying chunks when they're out of range. And because these are happening right next to each other, these arrays will be synced up, so we can use the coordinates to find the object references and vice versa. Okay, so now that these are being added into here, each time one of these is spawned, what we could do down here is we could grab the chunk coordinates here that are being generated from the loop and added to our player coordinates. And we can break the int vector and check if that's... no, we don't want to break it. All we want to do is we just want to grab the current coordinates and see if it's contained. Okay, so that goes up there, just like that. So what this check is doing is I'm just going to comment it so it's easier to read later. Does this chunk coordinate already contain a chunk? Question mark. If it does, we don't want to spawn. We only want to spawn if it doesn't contain it. So we can put that down there, and we just need to fix this thing up here because I left this all broken and shit. So this is where we want to grab our chunk coordinates. Chunk coordinates is the coordinate of this chunk in the world, and in order to get the actual world space of that coordinate that we're going to be using as the transform, we need to multiply the chunk coordinates by the chunk size. So that can go in there, that can be saved, and let me just, can I highlight all of that? I'm just going to call this spawn a new chunk at this loop's coordinates. Okay, oopsie daisies. Let's see if that works. Before I do that, let me... Oh no, we can probably just do it. Actually, before we do it, I want to do that. I want to do this on begin play as well, because last time it didn't actually spawn them in until I had wandered off the edge. So the first thing that we want to do when the game begins is just spawn the new chunks in the render range. And that should be all good. So let's play as a new editor window this time. And now you can see out there we have some chunks, and they're continuously spawning, but they're not disappearing behind us. But the lag has gone though, because it's not spawning as much each time now. It's just spawning the ones in front of us. And in case you can't see that, I'll just change the color of this. Let's try this cube material. And I might also just change the render range, because 5 was a bit too much. They were way off in the distance and it was a bit hard to see. So let's hit play. Now you can see. See that? They're spawning as we get closer to the edge. Okay, that's all good. I'm just going to take a breather and think about the next thing that I'm going to do, and I'll be back. Okay, so I took a bit of a break and I had a look at what we needed to do next and gave myself a headache trying to figure out some booleans and other stupid shit, but I got there in the end. So what we need to do now is, this is in the spawn new chunks within render range function. The logic before we spawn a chunk, I just need to pimp this out just a little bit here. So what we're going to do is just disconnect all of this for now, and I'm just going to put a comment here and say should not hang on, let's say should spawn chunk, question mark. And the conditions for that are going to be, the first condition is going to be, is there not a chunk already at this coordinate? So this here is checking if there's a chunk at this coordinate. We need to make that a not boolean because we don't want there to be a chunk at this coordinate, so that's going to be the condition. But we also want another condition, so let's use an AND. So this is where we type in and the second condition is going to be, is this coordinate within the render range? I'm going to put a capital there because that's a variable name. So we're using an AND boolean thing. And what this second check is this coordinate within the render range? The reason that we're doing that is because what this is doing is generating a grid in a square, and then spawning all of those chunks in that square. But I don't actually want it to generate in a square. What I want it to do is to kind of generate in a circle. So if you look at this grid just like here, like that, and the player's in the middle, the chunks that are directly on the sides are much closer than the ones that are way off in the corners. And sometimes if you're on a really big map, the ones off in the corners are just going to be too far away for you to see or whatever. So what we want is a nice circle where we're only spawning chunks in a circle at an equal distance apart from the player. So to do that, we're going to need to grab our chunk size and our render range, and this is, we're going to multiply these two together to give ourselves the render range in world space, in a world space float value, in an actual distance value, because this is just the number of tiles that we're rendering in. We need to convert the tiles to the actual distance, so we're multiplying the number of tiles by the tile size. We're going to be needing a less than thing, and we're going to need to plug that into the second one, because what we're going to be doing is checking if the distance from the player to the tile is actually less than the render range. And if that returns true, and this returns true, then we spawn a tile. So this will be plugged into there just like that. So that is probably a lot to think about. I don't know, it might be, it might not be. Maybe I just explained it poorly and it's actually very simple, but this has given me a headache to think about. That's what it looks like if you just want to copy it, pause the video or whatever. But let's just finish this off. So we need to grab our temp x and our temp y. I'm going to be multiplying these by floats just like I did before with the render range, because we need to convert the loop integer to an actual position in the world. So if we multiply that by that, and then we say make vector like this, now what we get is an actual physical coordinate based around the world space 0, 0, 0 in the world. So then what we can do is we can get the length of that position, and then we can check that against the render range. So what this is essentially doing is this whole thing here is returning the distance from the position of that chunk in the world relative to the player, wherever the player is, and then checking if that distance is less than the render range, and if it is, then we spawn the chunk. So that's how that looks. If you want to copy that. So let's just say play. Is that spawning in a circle still? Or a square still? I think it might be, you cheeky bugger. What if we make the render range like 5 or 6 or something? Yeah, see that now? See over on the edge? It's probably a bit hard to see, but what if I just change the quality a little bit? It's on scalability 0 right now, but if I bump it up to scalability 1, there you can see that it's actually spawning in a with rounded edges. It looks a bit shitty though. I wonder why. Less than or perhaps equal to? What if we type in less than or equal to? That's probably not going to do any difference, but let's just try it. Oh yeah, kinda. Yeah, because now we got that one out there as well. Yeah, so that's kind of working a bit better. It's doing it in a circle, but it's not despawning the ones behind us, so that's the next thing that we need to do. I might just pause this video there just so I've got these clips separate, just for my own. So what we're going to do now is, I might just leave all that there. That's fine. Actually, let's comment that and say, should spawn chunk, question mark. And then that one there is spawning the chunk. So now what we need to do is, when the player changes coordinates, we're spawning new chunks within the render range. What we might do before that happens is we might just do another function which is going to destroy all the chunks that are out of the render range. So this can be destroy chunks outside render range is what we're going to call that. And this one should be easier, I think. So if we grab our current spawn to chunk coordinates, and we can do a for each loop, this is every coordinate that currently contains a chunk. What we could do, I wonder if we can reuse that bit of logic from before. So in our new spawn chunk thing, no, probably not. Okay, so let's just go back to our destroy chunks outside render range. I'm going to have to break the int vector here. Okay, so the way that we're going to do this is we're going to get the coordinates of the chunk. We're going to multiply those coordinates by the chunk size. So that'll give us the position of the chunk in the world. So we could probably make a vector there. That's the position of the chunk in the world, and then what we want to do is we want to get the distance between the position of that chunk in the world and the player's location. So we could say get controlled pawn, get actor location, and then that'll be the distance. Now, is the distance from us to the chunk's location, no, let's use a greater than the render range. So the render range is the chunk size times the render range integer. So let's go float times integer, put that up there so they don't cross over because I have OCD. Not really, but it still pisses me off when shit's like that, so maybe I do, I don't know. Let's put a branch up there. So for each of the spawn chunk coordinates, is the distance from the chunk coordinate to the player location greater than the render range? If it's greater than the render range, we are going to grab, let's grab this array index, and we're going to say get copy. You know what, I don't want that dragging all the way across there, so what I'm going to do is I'm going to promote this to a local variable and call this index temp for temporary, or you could call it local or whatever the fuck you want. It really doesn't matter, but I just don't like Y's crossing over. So I'm just going to put that into there like that so that it's not going all the way across. Isn't that so much nicer? Okay, so this check, what is this doing? This is saying, is this coordinate outside of the render range? If that's true, then we're going to be grabbing our chunk references thingo, and we're going to be destroying the actor at that index. So these two things down here, these are synced up, so the coordinates in this are in order with the coordinates in that. So if the coordinates at this index are out of the range, we can use that index to get a reference to the actual physical actor of that chunk, and we can destroy it. And then after that, what we can do is we can say remove index of the coordinate array with the same temporary index, and just to be safe, we can also remove the same index of this one, because I'm not sure if destroying it actually removes the index from the array. We want the arrays to stay in sync, so what if we try that? I think that should do the job. Okay, let's just give that a shot. They're still spawning in. Are they breaking behind us? Nope, they are not. And the reason for that is because we need to put the actual function in. We made the function, but we're not using it. So let's destroy first and then create second. Just because that'll be, when there's like lots of tiles and things, it's better to destroy the ones that are irrelevant before creating more that are relevant, so that there's less loaded in at any given time. Okay, it's not perfect, but it's really not perfect, but it seems to be kind of working. Yeah, well, they're all breaking, they're all disappearing. It's just happening in a weird sort of way. Let me just reduce that size so we can see it a little bit easier. So the render range, I might bump that down to 3 again. Yeah, so you can see that they're spawning very well. And they're disappearing pretty well. Yeah, look, it's not perfect, but hey. Nothing is. Okay. I guess the final thing to do is to just pimp out this chunk blueprint a little bit, and then I might wrap up this tutorial. So let's delete the plane. Let's add in an instant static mesh. That's very important. We're going to be using a cube, so if you have starter content enabled, grab the, I think we want this one. Do they really have that much of a difference? That one has more triangles than this one. I think we want the one with the least triangles, just for performance. So let's just chuck that cube in. Now if we go into, let's go into begin play. And what we're going to be doing is just generating a grid of cubes. So we'll have a for loop just like we did before, one for X and one for Y. I mean, we could probably do this exactly the same as we did before, honestly. So we could have what if we just call it num X, so number of cubes on the X, and we can duplicate that and have another one called num Y. And I might actually do the same thing that we did last time, so it's not really going to be the number of cubes on the X and the Y, but it's going to be the number from the center to the edge. So what it'll really be is it'll be more like num X, 2n minus 1. 2n minus 1. If that doesn't make a whole lot of sense, don't worry, it doesn't really matter. So let's just do the same here with this. So first index in there, last index in there. And I'm just going to put them under like that. Now I might do the same thing as we did last time and just have a loop X and a loop Y. And you might have noticed, if you've done procedural stuff like this before, you typically do this in the construction script, and you'd use these as local variables rather than actual variables. And I'm just going to make these two public because these two are editable, whereas these two are changed at runtime. The reason I'm doing this in begin play is because later on, when we're spawning a lot of these at once, if they're all in the construction script, they all happen in the same frame, which can cause the FPS of the game to just like drop from like 60 to like 0 for like a little while. And it can, I'm pretty sure it can also like crash the engine if there's a lot going on at once. So by doing it at begin play, what we can actually do later on is we could build our own for loops in here with a delay in between, and we could generate blocks each frame rather than all at once, so that the world loads in smoothly rather than all together. That's just a minor thing for now that might become more important later, but that's just why I'm doing it in begin play rather than the construction script. So what I'm going to do here is I'm just going to say add instance, instance static mesh is that one up there. I might actually just change the name of that. Let's just call this block ism ism for instance static mesh. And we're just gonna make a vector. Actually, no, you know what? We're gonna make the transform this time. Make transform. Now this is a relative transform, I think. So if we leave the location as 0, 0, 0, it's going to be 0, 0, 0 relative to here rather than the world. That's just important to know. So what we're going to do for the transform is we're going to need a variable here which is going to be called voxel size, I think is what we'll call it. A voxel is just I think it's just a cube, or it's like a point. I'm not really sure exactly what it is, but voxel for me is just going to mean the cube size. So if we have voxel size and we set that to say 100, because we're using cubes of 100 width, which we can change later, we can make them bigger or smaller. We're going to be grabbing the voxel size, and then we're going to be multiplying by an integer. And this is just the same thing that we've been doing all day long. We're not going to be grabbing that, we're going to be grabbing the loop x and plugging that into there, and then we're copying that and doing the same for the loop y. And I think we can just make a vector right here just like this. And if we wanted this voxel size to be changeable, what we could do is we could also change this scale down here. 1, 1, 1. Grab the voxel size, and then if we divide that by 100 and then plug that into there, this should automatically scale the cube for us correctly. So for example, if we had our cube's 100 width, which is why we've got the 100 down there. If we set the voxel size to 200 because we want our voxels to be 200 width, 200 divided by 100 is 2, so it'll automatically scale the size to 2, and then the spacing will update automatically. So I wonder if that's actually going to work. Let's just change this number to okay, so this is actually going to be quite important now. We're going to need to try and get the spacing right. So if we have 10 num x and 10 num y, 10 times 2 is 21, minus 1 is 19, so the chunk size here is just going to be 1900 for now. Later on we will change all this and get everything doing the math for us, but for now let's just see what happens. Okay, so now it looks like we might have some cubes. Yeah, and the tiles are spawning in over there, and back there they're despawning as well. Everything is still very far apart and it's a bit hard to see, so I'm just going to reduce the render range, or maybe we can reduce, let's reduce this, let's make these a bit smaller. Let's go 5 and 5 for you, which means in the player controller this size will be 5 times 2 is 10 minus 1, 900, let's go 900. And the last thing is the material on this didn't seem to be working for some reason. So if I just add in an instance real quick just to see what's going on there. What if we try, what, I don't know, basic wall. Material doesn't want to work. Yeah, that's fine. We'll figure that out later. So I think that's all good. One last thing that I might do, just so you can see that these are all blocks, is I might just type in random float in range here for the z, and let's type in, like, I don't know, negative 50 and maybe 50 or something like that, just so we can get a bit of variation. That's probably a bit too much. Negative 10 and 10. Has our material worked? Okay, our material's worked. So now let's see what happens. Okay, there we go. Look at that. So that's our world. And they're spawning and they're despawning. And are they all the right spacing apart? They look like they're the right spacing apart. And of course they've got that noise because we just added in a little bit of variation to the Z. What we're going to be doing later is we'll do the Z from a noise function, a simplex noise function. So instead of just it being random like this, is we'll actually be able to generate continuous curves across from chunk to chunk. and of course we'll also be doing the caves as well, so we won't just be generating a plane of blocks like that, but we'll also have a Z loop in as well. So maybe we could just add, oh no, I won't add that in now, I'll add that in next time. But what we'll do is we'll loop through the surface and then we'll loop through the Z as well, so it'll do layers and it'll have depth. And for the depths that are below the surface layer, that's when we apply the noise. So we'll have like a branch here for the Z loop, and it'll check, is this a surface layer, apply 2D noise. If it's below the surface, apply the 3D noise, which will start putting in gaps and caves and things like that. Okay, I know I didn't explain all of this perfectly because, I don't know, I'm just quite tired today, but I really wanted to do this tutorial and not put it off for too much longer, because I feel like I've been promising an infinite world generation tutorial for a while, and I definitely have been. So this is it. This is how you get an infinite world. You could do this with levels instead of chunks. So here we've got the chunk blueprint, which is essentially a level, but in the player controller, if you wanted actual levels instead of spawning chunks, is you use a streaming level node here instead of a spawn act node, but it gets difficult to delete those, which I explained in another video. I'm pretty sure they're just stored in memory and you can't actually destroy a level once it's been streamed, so that kind of sucks. But I think you can do it in C++, but that freaks me out still. One day I'll learn it, but not today. So if you have any questions about any of this, drop them in the comments. Someone might be able to help you out, or I might be able to help you out. In the next video, I guess we'll look at importing the Simplex noise plugin. I'll start applying surface noise, and then we'll look at 3D noise and generating big 3D chunks. And then maybe after that we might also look at doing some materials and things, so we could have like dirt material below a certain threshold, or we could have, you know, like snow up on mountains, or even just like different random positioning of, you know, like, I don't know, you might want to put a tree every so often, like on a grass block or something. We might have a look at a few things like that. We might also look at adding and destroying blocks. So the way that you do that is in this static mesh instance is you'd use like a line trace where the player would hit a block, and then you'd use the hit result of that to find the instance of the block that was hit and then destroy it, or place a block. So you'd add an instance. You'd use the add instance node to place a block instead of destroy it. But that's it for now, guys. Hopefully this helps. I'll be back soon with another one. Have a good day.